stop it. All right, so I'm hoping you maybe have heard of vectors at some point in a physics class or some kind of general science class, but it's not a big deal if you haven't. A vector is a quantity that has both magnitude and direction. Okay, any quantity that has both magnitude and direction. A scalar is just a number. Okay, it has magnitude only, no direction. The magnitude of a vector is the length of a directed line segment, and the direction of a vector is the directed angle between the positive x-axis and the vector. That's a lot of words, okay? A vector is drawn like a ray. Sometimes they'll put a little segment here at the end to show that it actually ends, okay? It doesn't keep going, but the arrow shows the direction, all right? And if we were talking about this vector, we would say that it had an angle of, maybe 30 degrees, okay? It's always measured off the positive x-axis. And then the length is called the magnitude. And the magnitude can be, a force. It could be newtons. It could be a weight that it's pulling. It could be miles an hour. It could be so many feet long. It's any kind of number is a magnitude, and then has a length, a direction. It's called a vector. So a vector can be represented graphically using what they call a directed line segment. In other words, it ends, but it has direction. So in this picture, they show a dot at either end. Sometimes this is just a line. P is called the initial point. Or the tail. And Q is called the terminal point or the tip. And vectors are denoted with like an arrow or ray symbol. This vector PQ, sometimes books will use this notation with like a half an arrow. Okay, like that, or a bold-faced. Okay, so I'll just tell you if it's a vector. We're not going to worry about fancy notation, but if you see that something like that, that's just different ways of denoting a vector. All right, parallel vectors are two vectors that have the same or opposite direction, but not necessarily the same magnitude. So basically they have the same slope, so they're parallel, okay? So it could be like this, and one could be like this, but they have the same tilt, but one can be longer than the other and going in the opposite direction. Does that make sense? Parallel, okay? Equivalent, same magnitude and direction. So let's just draw two that are exactly the same, okay? Same magnitude and direction, go in the same direction, they're the same length. They could just be different places. Some opposite forces mean they have the same length, but opposite directions, okay? And it says the opposite vector of A is written as like negative A. So opposite forces would mean like one is pulling this way and the other one is pulling this way. So they're exactly the same length or amount of force or whatever, but they're going in opposite directions. On this picture, they just want us to pick one of those words for those. A is going like 2 to the left and up 1, and E is going down 1 and 2 to the right. What do you think there? Yeah. Are they also parallel, guys? same or opposite direction, but not necessarily the same magnitude. I think they're also parallel. I feel like opposite is a better word, more specific. I and F. I is going up 6 and over 2, and F is going up 6 and over 2. Those are actually equivalent, right? I think they would also be called parallel, but equivalent is a better word. D and E. This one is going down 2 and over 4, and this one's going down 1 and over 2 in the same direction. Those would be parallel. B and G, down 4 and over 4, and G is up 4, or right 4 and up 4. I think nothing, right? They're not going the same direction. They're not going opposite directions. So opposite, yes, except they have to be pulling exactly opposite directions. So like, want to be opposite of this, it would need to be going that way. See, this one's going still to the right. If those two forces acted together, so one was pulling it this way and one was pulling it this way, the object would still move to the right. Does that make sense? All right, C and H. Opposite, maybe? Yes? Okay. All right. Not on a quiz, just thinking about these things. This idea you do have to know how to do. It says draw an arrow diagram for each quantity described, include labels on each diagram. So we are always going to work off the positive x-axis unless they tell us otherwise. So this one says 60 pounds of, whoops, that I should have made that dotted or something because that's not the vector. That's just the positive x-axis. The actual vector says vector V is 60 pounds of force at 125 degrees. So we're going to move around into what would be quadrant 2, and we're going to label that 125 degrees. I don't care how accurate you are, just so it's into quadrant 2. And we're going to say that it ends out here somewhere, so you can either just draw an arrow. I don't really care. You don't have to put the little line if you don't want. And we're going to label this 60 pounds. And that's it. Okay, 60 pounds, 125 degrees. We're going to come back and do something more to this in a minute. Oh, and we could label it V somewhere, but I'm not going to be picky about that. 55 miles an hour at a bearing of. Okay, remember we did these briefly before when we were doing some trig topics, but this means off of south, go 45 towards the east. So off of south, 45 towards the east, east, south. Now, we would actually put a degree in here because that's off of the positive x-axis. What degree would that be off the positive x-axis, guys? If it's 45 in here, it's also 45 here, but it's negative because it's going down. And the length of this vector is going to be 55 miles an hour. I know miles an hour is a weird length, but that's what it's denoting. I think we got a couple more of these. 30 meters at a bearing of. Anybody tell me where we would draw that? it says north, which would be here, right? West, which would be here. And our positive x-axis would be over here. Okay, off of north, 40 degrees toward the west would be somewhere over here. 40 degrees off of north. So what's the number off the positive x-axis, guys? 130, 90 plus 40, everybody okay? And then we're going to label this 30 meters in length. And we could label it R, but I'm not going to worry about that. All right, can you try this one? 150 yards at 20 degrees to the horizontal. So just your basic 20-degree angle, just a little. And we're going to label it 150 yards. Okay. Seem all right? Can do those? All right. They're just a picture at this point. What we want to know about them eventually is their components, okay? Vectors can be resolved into horizontal and vertical components, and we're going to use this word components to help us remember that we're going to use these funny little vector parentheses, okay? What we want to do is find the x and y components. So we have an example that says Jamel pulls on the end of a rope tied to a dinghy with a force of 50 newtons at an angle of 60 degrees with a horizontal. So just like we were just doing, we would say off the positive x-axis, 60 degrees, and it was 50 newtons of force. Now, if we want horizontal and vertical components, this is just an x and a y, and it's a right triangle, guys, yes? So we can go back and use this stuff. Everybody with me? We're actually going to make this really easy in just a second. But if this says 50, and this is 60 degrees, how could I find x? This is the hypotenuse. This is what? Adjacent. So I could say the cosine of 60 equals x adjacent over hypotenuse. And then I would need to multiply. So I'd end up with 50 times the cosine of 60 degrees to find my x component. To find my y component, this is opposite. So I could say the sine of 60 degrees equals opposite over hypotenuse. And then I would need to multiply 50 times the sine of 60 degrees. Well, this is going to work as long as we always have an angle off the positive x-axis measured correctly in either a positive or negative amount. It's always going to give us our x and y if we simply do the length times the cosine to find the x, and the length or magnitude times the sine to find the y. Okay, so it's always the magnitude, which we're going to also call a radius eventually, times the cosine for the x. Does that make sense? Cosine is x. Does that sound familiar? And the length times the sine will give us the y component. So if we can just remember that, we don't have to do a lot of extra thinking. So we're going to go back. They finished this one. They typed 50 times the cosine. What mode should our calculator be in for these questions? Degrees. Yes, the angles we're talking about are degrees. So we need to make sure we're in degree mode. And then we're just going to go back and do this for all of the questions we just skipped. See, They typed 50 cosine of 60 and got 25, 50 sine of 60 and got 43.3, and it could be written like this. All right, that was the example that they already did there. We're going to go back and do the ones we just did. So number 1, we're going to find the components. What is our r, or length of the vector? 60. And we're going to multiply it by the cosine of the angle off the x-axis, which is 125. And then we're going to do 60 times the sine of 125 to find the y component. Seem pretty easy? 60 cosine 125, long as we're in degrees, negative 34.4. 60 sine of 125 is 49.1. Negative 34.4 and 49.1. That's wrong. Was this 4 and 49.1? Okay. Why did it come out negative? Yeah, doesn't it make sense that the components that are forcing it left and up? Yes, so it should be a negative 34.4 and a positive 49.1. You don't need to draw it on the picture, but it should make sense for that, okay? What kind of numbers is this one going to come out? Positive to the right, right? But negative because it's down. Okay, which angle are we using? We're using the one off the x, so we could either call it 315, is that right, guys? Or we could just use negative 45. We'll get the same answer either way. But it's got to be the angle off the x. And what is our length? Or our force or our speed is 55. So we're going to do the cosine of negative 45 and 55 sine of negative 45, or you can use 315. Now, what do you know about a 45, 45, 90? Both legs should be the same, right? So we should get the same decimal twice here. Except one's negative 55 cosine of negative 45 and 55 sine of negative 45. So we got a positive and a negative 38.9. Because it's to the right 38.9 and down 38.9. Okay, can you come up real quick with numbers 3 and 4? Oh, what angle are we using on this one? Yep, the length is 30, the angle is 130. Yeah, x and then y. So cosine and then sine. Okay, yep. Because the first one is just like an x. It's basically finding this length right here and this. It's like we're undoing Pythagorean theorem. We're finding those two legs. Okay. So 30 cosine. Negative 19.3 and 23 basically. Anybody do this last one so I don't have to type it? 150 cosine of 20. 150 sine of 20. What's after the 9? 9.5. So yeah, 141 maybe. This should be a little number, I think. Littler. Because it's clearly going further to the right than up with a little 20-degree angle, right? Did someone else get those two numbers? Okay. All right, so that's the first part of the lesson. And I want you to finish these three tonight for part of your homework, okay? Remember, you have to draw, label, and find the component form just like we did on those four, okay? Does that make sense? So you have to do both the drawing and the component form. All right, I want to start this next section though, because then you can do a little delta math tonight too, I think. So this says part 2, but we're going to start it today. It says when you know coordinates, okay? So we're going to know two coordinate pairs, and we're going to figure out what the vector would be that goes from one to the other. They say you take the second x minus the first and the second y minus the first. Let me give you an example, and then we're going to find magnitude. Okay, so here's their example. If we have an ordered pair that goes from 2, -3, it's already drawn there for you, to -4, 2, and you are going to have some of this on delta math that you have to drag. So it goes from there to there. So you're just going to, you would stick your cursor here and drag it over to here on delta math to show that that's what it looked like. Then what they have you do in delta math is drag it to the origin to find the components. We're going to actually use the subtraction. So if it went from 2, -3 up to -4, 2. Now, this, I usually do them in my head because I say to myself, the x went from +2 to -4. That's left 6. If I went from down at -3 up to +2, I went up 5. But the actual formula is to take the second one minus the first one, okay? Just like slope, only you're doing you're not doing like y over x. So if you went from here to here, it would be -4 minus 2 for the x's, and it went 2 minus -3. Okay, these are x's, and you do the second one minus the first one, and the second one minus the first one. All right? So, and then what they want, oh, that's not what's supposed to go in this blank at all. Sorry. Magnitude. Magnitude is the length of it. So if we know that it went left 6 and up 5, what can we use to find the length? Pythagorean theorem. Yep. So we're just going to do 6 or -6 squared plus 5 squared equals, and then we're going to square root it to find the magnitude. Okay, so let me go back to that slide. It says here, once you know the components of the vector, okay, so you have found the component form like this, then you are just doing Pythagorean theorem to find the magnitude. Now, magnitude, they write like with this absolute value symbols, or some things use double absolute value symbols. I think in delta math they use the double absolute value to indicate magnitude or length, but it just means you're going to do this: a squared plus b squared from the components. Everybody see that right in there? So for this one, we would have done -6 squared plus 5 squared. Let's see, that's 36 and 25. Is it 61? You can just ignore negatives, guys. Save yourself. You won't need the parentheses because it's going to become positive when you do Pythagorean theorem. So just type 6 squared plus 5 squares. All right. And you could give me a decimal, whatever it asks for. I think it asks in delta math for exact. All right. So let's fly through these, a couple of these at least. So if you want to do it in your head, it says up here you're going from A to B, so you're going 12 to 52. You went what? Otherwise, it's 52 minus 12 is 40. And 41 to 33, you're going down, because opposite would be 33 minus 41. Is it negative 8? Did I subtract right or not? Okay. That's the components, okay, just so we're clear on the vocabulary. The magnitude is we then do the Pythagorean theorem to those numbers. Is it like 1664, or is that not big enough? And does that come out nice? No? Okay. Yes, that's a great question, because it says this way. It says A to B. So if we went from A to B, we were going to the right, so it needs to be positive. So that means you subtract in the other order, okay? Otherwise, the signs will be backwards, and then it would be indicating that it was going from B to A, okay? It is a little confusing, but if you think about, like, if I'm going from A to B, from negative 15 up to 7, I've actually gone 22, which was what you would get when you do 7 minus negative 15. That's what I like to do in my head, but I understand that it's a little tricky if you're not good with adding and subtracting always weird numbers. This one from 0 to negative 19 is just down 19 because it would have been negative 19 minus 0. And then if we do 22 squared plus 19 squared, again, I'm just ignoring the negative because once you squared, it's going to become positive anyway. I don't have any idea what that is. Okay. And I'm really not worried about simplifying these. You can leave them ugly. You can give me a decimal. I think in Delta Math, they just want exact, and I have no idea if they want you to simplify them. I'll see. We'll do an example here. 1 second. All right. This, can you do this one on your own? A to B. I got a negative, negative. Did anybody else get a negative, negative? And I think just square root of 10, isn't it? All right, I think I'm gonna stop. I really want to do the angle too, but it gets a little confusing. Maybe I'll preview it. We have time. No, I'm gonna stop. Okay, so I'm not gonna stop the recording because I'm gonna go to Delta Math and show you a couple examples, okay? So on your Delta Math tonight, it asks you to add graphically. What this means is they have drawn the vectors for you, okay? They drew a vector that went from 0, 0 to negative 1, negative 5. That's this guy. This is U. And V went over 5 and up 4. That's V. To find the sum, it says click and drag either vector to add graphically. We haven't talked about this yet, but it's really easy. You click on one of them and you drag it until it ends at one and starts the next one, okay? So I could drag it there. I could put this one back and drag this one down, maybe I didn't put it back right. Could I have dragged that one? Okay, now it's not happy with me. But the end of one has to be the start of the next one. And then they want to know, where did you wind up? Well, where did we wind up, guys? Over 4 and down 1? So this would just be 4, negative 1. Okay, let me show you another one. So they've drawn the vectors for us. We have to pick one of these and drag it. So we don't want them arrow to arrow. Okay, where one ends, the next one starts. So it does this. It's called tip to tail. If you take physics. But where one ends, the next one starts. And where did we wind up? -3, -7. Does this seem pretty easy? You can watch their little video if you get stuck, but so that's adding them graphically. If we go back, this is what we did, what we just worked on, okay? It says determine the components of vector v. So it starts here and goes to here. So you take the second one minus the first. -8 minus -6 would be -2. And 4 minus 2 would be +2. And that's it. Okay? Those are both real easy sections. The last section, you're not going to be able to answer all the questions yet, so you might want to wait, but I could just show you. What you have to do is draw a vector from 8, 5 to 5, 2. Okay, so you go to 8, 5, click, drag over to 5, 2. Seem okay? And then it says move the vector so that its tail is at the origin. So you're just going to take this and move it over here. Now, what are its components? If you had to go from the origin, you would go left 3 and down 3. Everybody good? Left 3, down 3. Now we did magnitude. Magnitude is just the square root of, what's 3 squared plus 3 squared? 18? Whoa, I didn't want that there. Whoa, what did I do? Square root of, I'm going to put square root of 18 and see if they give us any grief about that. Now, we have not done direction. Can you guys guess? Because it's going right through the middle of that. Wouldn't it be 180 plus 45? Just because it happens to be, they're not all like that. And we're going to learn tomorrow how to do it. But I just want to see if they'll take that radical. What do I have? Okay, it didn't need me to simplify the radical. Yeah, they even left it, I think, didn't they? Yeah, they left it square root of 18, okay? That was my question. Do we have to make it like 3 square roots of 2? What we're going to do eventually is we're going to always do inverse tangent of the y over the x, and then we're going to have to figure out what quadrant it lands in. So this one you would have had to do 180 plus 45. But I can try one more if you just want to see it. I want to get this out of the way today. If you start at 4, -2, it said drag over to -2, 0. Once you let go, it wants you to drag it to the origin. We wound up at -6, 2. You do Pythagorean theorem, that'd be 36 and 4 is square root of 40. And then I need someone to type for me. Second tangent 2 over 6. Can someone do second tangent 2 over 6 real quick? So 18 degrees. That is the angle in here. So we would do 180 minus 18. Well, actually, we should have done second tangent 2 over -6. Can you try again? Second tangent 2 over -6. Should be -18.4. Okay. Now, -18 degrees would wind us in quadrant 4. We would need to add 180 to put in this quadrant. So can you add 180 to that real quick? So 162, because it says nearest degree. All right, we'll spend more time tomorrow talking about that, but if you want to try it, I can tell you that here on this, the definition to find the angle down here, we're going to do tomorrow, it is inverse tangent of B over A. When you have a vector that goes A, B. It's always inverse tangent B over A. But there's times when you have to add 180 and all kinds of stuff to get it in the right quadrant. So we'll talk more about that tomorrow. So tonight, you finish those 3 questions on worksheet 13B, and you can start on vector practice 1. If you wanted to look at vector practice 2, a whole bunch of it is really easy stuff, but I'll go over it tomorrow, okay? Any questions?